Okay, welcome once again to Flight Theory and Aerodynamics. Today the subject is continuity equation. Continuity equation. This equation is very important to know and understand, because this is the parent of the Bernoulli's equation. You know about the Bernoulli's equation? Well, the Bernoulli's equation is an offspring of the continuity equation. Okay, now every time we talk about continuity equation, think of constant airflow, constant mass airflow. And then to a constant mass airflow is called steady state flow. Okay, so we know we have a constant mass airflow that is going to enter a pipe of varying cross section, and an example of that is this. Okay, this is a pipe with 3 stations: station 1, station 2, station 3, and then you can see the mass airflow entering the front end of the pipe. As you can see, the pipe, the cross section, you have the middle section of the pipe, which is I can say it is squeezed up. It is squeezed up a little bit. Okay, so now you have that pipe, and then the airflow, the mass flow airflow is going to go into it, through it. But that pipe only, okay, the air is going to flow only through the ends, through the front end and the back end of the pipe, not through the sides of the pipe. There's no flow. There's no airflow through the sides of the pipe, just through the ends, the front end and the back end. Okay, so the airflow that enters the front end of the pipe at a given unit of time, it equals the airflow that is going to exit the end of the pipe, because the mass airflow going through the pipe is constant. It's a steady flow. It is a steady state flow. There's no change. It is the same at station 1, station 2, and station 3. So when it comes to continuity equation, this is a very important notion to remember. Continuity equation, we're talking about steady state airflow, constant airflow. Okay, so the mass airflow equals the volume of air multiplied by the density of the air. Okay, so one thing that we need to understand, that at each station of the pipe, the mass airflow is the same. Okay, let's say that means station 1, station 2, station 3, 1, 2, 3 equal constant airflow. Now, what is the question that we need to ask ourselves? What is the volume of the air going through these three stations of the pipe? What is the volume? What is the volume at each station? After all, the continuity equation is about the relationship between velocity and cross-sectional area. So in this case, we can safely say that the volume of the air at each stage of the air going through the pipe, at each station, station 1, station 2, station 3, the volume of the air is the velocity. If the velocity of the air multiplied by the cross-section area at that station. Okay, station 1. Okay, now you're going to have station 1. The volume is going to be, if you want to include the density of the air at station 1, the volume of the air is going to be density times A1, which is the area at that station, at station 1, A1 times velocity 1. Okay, station 2 is going to be the volume of the air at station 2 is going to be uh, uh, density times A2. A stands for area. A2 times velocity 2, and the same for same procedure at station 3. So the only thing we know that since since the mass airflow going through all the three stations, all the three stations must remain constant. So that means we have density A1 V1 equal density A2 V2, A2 V2 equal density A3 V3 equal constant flow, constant mass airflow, steady state flow. So in order to have continuity equation, you must have constant mass airflow going through the pipe. Okay, so it is important to understand the concept of continuity equation. Okay, because this is the same. When I cover Bernoulli's equation, the continuity equation will be present. It will be present in the Bernoulli's equation. The only difference is that the continuity equation is about the relationship between velocity and cross-sectional area, of the air going through a pipe of varying cross-section. Okay, remember that the pipe, the cross-section, the cross-section of the pipe vary. Okay, you can see the shape. So the relationship between velocity of the air and the cross-section area at each station, that's what the continuity equation is all about. That explains, continuity explains to us that relationship, velocity, cross-sectional area. In the Bernoulli's equation, which I will see in a future video, that concept is present, but the difference is the continuity equation does not explain the differences in static pressures in the air going through the pipe of varying cross-section. But the Bernoulli's equation will do that. It will be in addition. It will be in addition to the continuity equation. So something that I was thinking about. We know that I think I said that the mass airflow equals um, the volume of the air, the volume of air multiplied by the density of the air. So if the velocity of the air at each section of the pipe is velocity multiplied by cross sectional area. So I can say that I can replace some letters and then say that actually the mass airflow is density times area times velocity. I was thinking about that because when you do those calculations, you can kind of shuffle some numbers, letters around to bring the formula into a simpler state. So that's all. That's all for continuity equation for today. Next time, of course, I'm going to cover the Bernoulli's equation. So meanwhile, I wish you a fantastic day.